welcome back, guys. We're going to be on page 46 now, and what we're going to be looking at is the angle addition postulate itself. Okay, and what the angle addition postulate says basically is the two parts of the angle are the two parts that make up one bigger angle are going to add up together to equal the measurement of the bigger angle. Okay, and so for example, if I had this angle here plus this angle here, it's going to be equal to this bigger angle out here, and that's kind of what I've written here: part plus part equals whole. That's very straightforward, very much just like the segments, okay? And so if we wanted to solve this either for x or for one of the angles, and we'll keep it simple, we'll solve for x, then we would do the parts. So 5x minus 10 plus the other part, 2x plus 3 equals the whole. In this case, that's kind of what this is representing, 10x minus 28. And then when we do some algebra, we've combined some like terms. Here in this case, we have, this is 7x minus 7, and this is still 10x minus 28. And so what we would do is simply solve for these. We subtract 7x, you get 3x. You add 28, you're going to get 21. So 3x equals 21. So we would have actually 21 equals 3x, and then dividing by 3, you get x equals 7. Okay? And that's the generic idea of the angle addition postulate, and that's what you're going to be working with. Again, identical to the segment addition postulate when we were talking about angles. Okay? We're also going to have angle bisectors. Remember, we had a bisector when it came to a segment, and when it came to a segment, the bisector was intersecting at the midpoint, basically cutting the segment into two congruent parts. Same thing here. The angle bisector is going to split the angle in half, so that both halves of the angle are going to be equal. So maybe we had, let's say, a nice round number. Let's say we had an 80-degree angle, and we split it in half, right? That means this would be 40, and this would be 40. Now, when we did segments, we drew those little lines. When you're doing angles, you're going to draw basically a little symbol in the corner that looks something like that. Or let's see if we can make it a little bigger just to make sure y'all can see it. If you have one angle and another angle that are equal to each other, you're going to draw an angle marker and put a dash through it. Angle marker and put a dash through it is probably the most common. Another way that you might see it is they're going to draw an angle and another angle, and maybe they put two lines to show you that those two angles go together. Okay? And you'll see both of those notations in quizzes and things like that, just depending on which book or which resource you're looking at, okay? So these markings are letting you know that the angles match. Those angles are congruent to each other. And when you have an angle bisector, if you have those markings, it's letting you know, hey, this middle line is going to be your angle bisector, all right? Now, that's the idea with the angle bisector. We talked about the angle addition. Let's get to the complicated part, all right? And what's the most complicated part? It's the English, right? How many wish every math test had no English on it? Well, English shows up. So here we go. I wrote some English down here in the corner. It's in blue. Hopefully you can see it. I'll read it to you. Don't stress too much. So it says, angle ABC is bisected by ray BD. How do I know it's a ray? Because of the symbol on top. So make sure you learn your symbols. Okay? So angle ABC is bisected by ray BD. If the measure of angle ABD is equal to x squared, the measure of angle ABD is equal to x squared, and the measure of angle ABC is equal to 16x, is angle ABC acute? What? What? Hold on, let's back up. Okay? What does it mean to be acute? Well, I got it drew over here, but let's get real technical. Acute means an angle that measures somewhere between 0 and 90, not including, yeah? If you include 0, it's not an angle. If you include 90, it's a right angle. So we're talking between 0 and 90, all right? So really, we need to solve for the measurement of ABC. And we need to verify whether or not ABC falls in between 0 and 90, and that will answer our question for us, okay? Now, how do we do that? Well, the same way we do most of these problems, we need to draw a picture. So what I'm going to do is I'm actually going to erase this section right here. And so we'll come in, we'll make all this disappear. We'll get a nice clean board so that we can see what we're doing. And we're going to draw a picture here. Now, how do I draw this picture? Should I draw it as an acute angle, obtuse angle? See, that's the tricky part, right? You're asking yourself, well, do I make it a big angle? Do I not make it a big angle? It doesn't matter, okay? I can draw an acute angle, tell you that it's 100 degrees, that makes it obtuse. Whatever the measurement is, that's going to define the angle, okay? So what I'm going to do is I'm going to draw pretty close to a right angle just to keep it kind of like we don't know what it is, right? And remember, my big angle that I'm talking about is ABC. So A goes up here. B is the middle letter. Remember, the middle letter is always going to tell you what the vertex is. That's the vertex angle. So B is my vertex angle, and that puts my C over here. All right, now I said it's bisected by ray BD. Notice that it starts at B and goes through D. I'm going to try to draw it about in the middle. All right, and so goes through D, right? So there's my drawing. Now, let's make sure we label this correctly. Bisect, that means that this measurement, whatever it is, I don't know what it is going to be equal to this measurement, okay? And I'll put my little tick marks there. That's what I'm going to use commonly, okay? So those two angles are equal to each other, right? That's all that first sentence. That's all from the first sentence. I haven't even read the second sentence yet. When I get to the second sentence, it says, if the measure of angle ABD, that's A to B to D, so we're up here, we're in this section right here, is equal to x squared, so I'm going to put an x squared here. All right? If the measurement of ABD is equal to x squared, and the measure of ABC, now hold up, ABC is the whole thing, all right? This is where it's kind of hard to draw on your paper and hard to figure it out, but you've got to figure out a way to notate to yourself if you're talking about the whole thing. You can draw kind of a line over here, put your measurement. I'm going to draw one, I'm going to put a little arrow here, and I'm going to say that I'm talking about this whole thing, okay? This whole thing is going to be 16x. Now some of you are thinking, okay, he'd be an extra drawing that out there. I know, but it's okay. I want to make sure that I know I'm talking about the whole thing, okay? Now, what is the relationship? We'll think back to segments, right? With segments, we said, well, half of it times 2 would equal the whole thing, because it is half, right? So if I double this, it should be equal to this, or since these are equal to each other, I can put x squared here. Again, we're talking about the difference between x squared plus x squared, or 2 times x squared. Hopefully you both know that all of you know that comes up to 2x squared, okay? And we're going to set that equal to the whole thing, 16x. All right? Now how do I solve this? Well, basically I need to get x by itself over here, okay? And so that's my goal. My goal is going to be x equals. What do? First thing I'm going to do is divide by 2. I'm going to get x squared equals 8x. All right? Now some of you already know the answer, and that's fine, but let's kind of talk about what's happening here. This is x times x, and this is 8 times x. Well, I need to get x by itself, right? I can actually divide out the x on this side because I need to get it over to this side. And notice what happens. I get x equals 8. Another option, what some of you might do, is you might take the square root of x squared and the square root of 8x. The problem with that is that doesn't get you anywhere there, okay? Not cleanly, not prettily. So I would not suggest that. Don't deal with that. Don't deal with the exponent. Remember, when you're dealing with algebra, solving algebra, you want to use backwards PEMDAS, and I would much rather get rid of multiplication instead of dealing with that exponent. Okay, so don't do this. Don't. I don't say that very often, but seriously, I think it just causes more problems than is necessary. So, x is 8. Awesome, so we got our answer. X is 8. No. What was the question? Is ABC acute? Well, I think it's pretty, but I don't know if it's acute, so let's find out. We need to plug the 8 back in. Where do we plug it in? We plug it in here. What do they ask us about? They asked us about ABC. This is ABC. So I need to know, is 16 times 8 give me an acute angle? What's 16 times 8? Well, 16 times 10 is 160. 16 times 2 is 32. 160 minus 32, I'm going to get 140. No. 160 minus 32, I get 128. Yeah? Now, is that more or less than 90? This is not acute. Okay? That means the answer here would simply be no. Now, I know that seems like a lot of work to get to know, but you're going to have problems like that, okay? And I don't want you to stress out. I want you to take your time, go slow, understand that it's not going to be any more complicated than that. And that's not that complicated when you break it down. So, what I want you to do, we are on page 46, yeah? You're going to do all of page 46, all of page 47, and you're going all the way to number 8 on page 48. So you're doing 5 through 8, all of it. There's some try-me's, there's all kinds of stuff there. I want you to read it, I want you to work it. It's going to take you a few minutes, and I want you to take it. Let's say 15, 20 minutes, somewhere in that range, okay? If you're done early, come back early. When you get to 20 minutes, here's the deal. I don't want you to spend 2 hours on this, okay? So at 20 minutes, if it's not making sense, you need to okay, hold up, what's going on? Right? Do you have one question left, or do you have a bunch left? If you have a lot left, if you're still on number 5, something's wrong. You need to go back and rewatch this video, or check out the next video where I go over some of these to see if that helps you. All right, I'll see you in a few minutes. Thank you.